Hi everyone, this is Dr. Sandeep, working as Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today I'm going to discuss about the outcome-based education. So it is also called as OBE. So it is outcome-based education. So what is outcome-based education? So this outcome-based education or OBE is a student-centric teaching and learning practice. So completely this type of methodology of teaching comes under the student-centric learning and teaching methodologies. And generally, this is designed based upon the educational programs based upon set of goals. That means, so for every program, we'll give some outcomes. So based upon these outcomes, we'll try to plan the curriculum as well as the methodologies based upon the student-centric, and generally it focus on measuring student performance to the outcome. So how we are measuring the student performance means based upon these outcomes. So we are designing the outcomes based upon the educational program, and of course this performance of the students again we are trying to bring out through these outcomes only. And OB maps and measures student performance at every step. So why this OB is very useful in today's teaching and learning methodologies means this OB helps us to find out how the student is performing at every step based upon the performance with these outcomes. So you have to design the outcomes based upon the program which we are going to conduct, whether it is a UG or PG, and then based upon these outcomes the student performance can be calculated at every stage. And the OBE model aims to maximize student learning outcomes by developing their knowledge and skills. So not only we can identify the performance of the students based upon these outcomes, and also with the help of these OBE models we can aim the students to maximize their knowledge as well as skills. And if you compare the OBE with the traditional educational methodologies, so what is the main difference between these two, the traditional as well as the current OBE methodologies? So in the traditional we used to carry the assessment based upon the ranks or the grades. Now coming to the outcome based education, that is OBE, desired outcomes, that means based upon the goals. Okay, these are being assessed. So that is the main difference between the traditional as well as the OBE. Coming to the next one, grades are derived from point on activities like assignments, exams, etc. So in the traditional, we used to find out the grades based upon the assessments we are giving and activities and etc. Now coming to the OBE, what is happening here? Completion of education implies the learner has achieved set of goals. So how do you decide whether the student has completed the course? That means based upon the set of goals or set of outcomes what we have designed. So if the student has achieved those goals or the outcomes, then the completion of education implies, okay, we can give the grades. So that is the main difference. So in the traditional, what we are doing based upon the assignments or the activities, but coming to the OBE based upon the outcomes, how the student has achieved the outcomes, based upon those we are giving the grades. And coming to the third point, in the traditional methodology, what we are giving here, judgment methods are shaped from previous results. So based upon those previous results, we are trying to give the judgment methods for the shaping or any difference to do in the curriculum as well as the grading point. Coming to the OBE, judgment methods are shaped from continuous evaluation. So what we are doing at every stage, we are giving some continuous evaluation process is being done. CAE1, CAE2. That means continuous internal examinations we have to perform. So based upon this continuous assessment, the judgment can be done on the student performance. But in the traditional, based upon the previous results we are trying to judge the performance of the students. And the other one is only summative assessments are done. So in the traditional, what has happened is the assessment is done only summative based upon the end of the syllabus. We are trying to give some exams, and based upon those exams, we are trying to find out the assessment. But coming to the OBE, here we are doing the both the summative as well as the formative assessment to find out the performance of the students. So here at the end of the semester, we are performing some examinations, as well as in the mid of the syllabus of the program also we are conducting some examination, that is the continuous assessment examinations. So based upon these formulative and summative, we can easily identify the performance of the students. So in the previous methodologies like traditional, they are using only the summative type of performance to find out the judgment of the students. Next is no feedback is taken for the traditional systems. But here, coming to the OBE, we have to take the feedback from the students, from the parents, stakeholders. Okay, based upon all these feedbacks, we'll try to design or modify the curriculum or the methodology of teaching. So all this can be done through the help of the OBE, outcome based education only. So these are the main difference between the previous traditional methods of teaching as well as the new trend of teaching, that is the OBE. So in this way, the OBE is very useful. It is based upon the student centric learning and based upon the set of outcomes designed. So based upon these outcomes, the performance of the students can be achieved, as well as based upon the set of outcomes, the performance of the students, we can enhance the skills as well as the knowledge. And after that, the grading can also be done by the continuous evaluation process, assessment process, as well as the assessment at the end of the examinations. So after all this, we have to take the feedback from all the different types of sectors, like from students, we have to take from the parents, from the stakeholders. Okay, if you collect all these cumulative of the feedback, then it is very useful for us to design the curriculum or any changes in the curriculum, as well as the how to design the teaching methodologies can be get from these OB. So this is how the OB is very useful. And if you see the framework, how the framework for the OB, that is outcome based education, if you see here, you have the course. Okay, so course assessment, course outcome attainment, you have to see. Next, the programs. For these programs also attainment. So attainment is very important for us. Next, the institutional assessment. So what are the courses we are taking, and these courses, which program we are conducting, whether it is a UG program or PG program or MBA. Okay, based upon these, you have to design your COs as well as the POs. Now, based upon this, we have to plan our curriculum, that is the syllabus. Next is the teaching methodologies, learning activities, assessment tasks. So, based upon these courses or the programs, so the BTech level will have a little bit low level compared to the PG level. So, based upon these programs, we have to try to design the syllabus as well as the what are the teaching methodologies are required for this, as well as the learning activities. Next, assessment, how to do the assessment. So all these can be designed with the help of these framework. Now the outcomes, the what are the outcomes we are designing. So these outcomes again has to be reflected with the help of these cognitive level. So that is the Bloom's level taxonomy. So we have different levels of Bloom's. So these Blooms we have to match to the outcomes what we are taking. And coming to the next program, we have to design the PEOs, that is program educational objectives. Next, POs, program objectives, and PSOs, program specific objectives. So like this, we have to design all these things and we have to map. Then only we can get the assessment. So here, because depending upon the assessment, we can change the curriculum as well as the teaching methods, learning activities, assessment tasks. So all these are clubbed together in order to reform the structure of the education of the program. So in this way, the OBE is very useful for designing of the curriculum, for teaching methodologies, how to design, how to give the assessment, and how to give the learning activities. So all this helps to improve the uh, performance of the student. That's why the OBE is a student-centric learning process. Now, coming to the subject. So, which subject we are going is here is the materials engineering. So, this course has a code of AME C07, and the program for this is the BTech, and this comes for the third semester for the mechanical engineering department, and the course type is the course core. It is a core type for subject, and we have for the regulation UG20. And here, since it is a theory, we have uh, 3 credits for this, 3 credits, and of course there is no practical, so that's why we have given nil credits for this subject. Now, for going to the materials engineering, so what are the prerequisites? That means if you want to study any subject, so before reading the subject, what are the basic knowledge you need to have? So first one is what? Engineering physics. If you have the concepts of the engineering physics, then it is very easy to study the materials engineering. As well as if you know the chemistry also, so then that is very easy for us to study the material engineering. So these are the 2 prerequisites to know the basics of physics as well as chemistry. Then you can easily understand what is there in the materials engineering. Okay. Now coming to the overview. What is the overview? So if you study the materials engineering, then you can what the outputs, the what are the outcomes you can get. So if you see here, the complete overview of the subject, materials engineering is a broad multidisciplinary approach. So this is very important. Multidisciplinary. So it is not restricted to only the mechanical engineering. Okay, since it is a multidisciplinary, you can apply this subject in any type of discipline. So that's why it is called as a multidisciplinary. So this multidisciplinary approach to understand the fundamentals of crystallography, microstructure, and the relation to properties of materials. So once you know the property of material, then it is very easy for us to identify the exact material to any product. So suppose if you want to design any product, okay, so you have to decide what material is suitable for that. So in order to decide the type of material used or applied, so how can you decide? If you know the properties of the material, then only you can identify the exact material to that object what you are preparing. Okay, so that's why the material engineering is very important. Why? Because you have n number of materials available, so every material has its own property. So we are using mobiles, electronic gadgets, okay, refrigerator, everything we are using. So everything is made up of some material. So this material, how you are identifying? So what material is suitable? How can you justify? If you know the properties of the material, then only you can identify the exact material to the corresponding object. So that's why it is a multidisciplinary. It is not restricted to only mechanical. So everywhere you can see in the civil structures, you have a lot of materials involved. So it has to bear a lot of load when you're constructing any bridges. So for that to support those loads to, okay, so what type of material is used? That is very important for the civils. And coming to the mechanical, you have heavy machinery. So it has to work at heavy temperatures, high temperatures. So what material is good to withstand those for the high temperatures and low temperatures also? So you have to decide the material there. Coming to the electronics, electronic gadgets, what you are using. So there also you have to select the different materials. So here, this material science is not restricted to only one subject. It is a multidisciplinary. So that's why here, what we are trying to do, we are trying to find out the fundamentals of crystallography, microstructure, and the relation to the properties of the material. So this we are going to study, and this course provides key information on phase diagrams. So how from one phase to another phase, how it is being transforming. So if you give heat or to the material, so from solid to liquid, liquid to gaseous, okay, it is changing its transformation. So how this transformation is being happening can be identified with the help of these phase diagrams. And physical chemical behavior of metal elements. So once you give the uh, heat to the materials, so what is happening there? The physical and chemical behavior of the material changes. So how it is being changed can be known if you know the if you study the subject of materials engineering. Intermetallic compounds. So what are the intermetallic compounds inside the material? This also can be studied with the help of these materials engineering. So thus there is a great relevance for this course in modeling the mechanical, aeronautical and civil structures with ceramics, glasses, polymers, composites. So if you study these subjects, you have a vast applications, you have wide applications in all departments. So if you go to the aeronautical engineering, so there is a designing of, suppose if you consider the wings, so we are using some reinforced uh, material there, glass fiber reinforced components. So these glass reinforced components, how we are deciding, so we have to apply some load and we have to test whether it is withstanding or not. So based upon the load conditions, you are changing the material. So how you're changing the material, if you know the properties, if you know the physical and chemical properties of the material, then only you can decide the material to design the wings of an aircraft. Coming with the civil structures, if you're constructing any road or a building or a flyover or a bridge, so everywhere load is applied. So suppose if you consider a road, a lot of heavy vehicles go. So these heavy vehicles load has to withstand by the road. So what type of material you have to use, how much thickness you have to use, what is the composition of the material you're using. Similarly, when you're constructing a building, so the concrete, whatever the concrete you're using, what is the composition, what type of cement you have to use, what type of steel you have to use. Okay, so all this comes under material selection only. So once if you know the properties of the material as well as the chemical, physical, mechanical properties of the material, then it is very easy for us to select the material. So how can you identify all these things? Means if you know the material science engineering, then it is very easy for us to do all these applications. So that's why it is a multidisciplinary subject. At present day, designs are based on many advanced materials. So in traditional, we used to use only some materials, but now in present days we have a lot of new materials are coming. A lot of composite materials are coming. Okay, so all these composite materials are coming with the help of the research only. So we are trying to identify different materials. Why? Because you want to increase the life of the any material you're preparing. So if you have a large life cycle, then it is very useful. Suppose if you're buying any object and it is used for only 1 to 2 years, what is the use? So if it has a large life cycle, large span, then every customer will come and buy your product. So these products has to be done by the latest materials which are having a good mechanical, physical and chemical properties. So all these are important to prepare any product. So this product design can be done with the help of the basics knowledge of your material engineering. So before going to learn these material engineering, we have some prerequisites given to you. So you have to go through those prerequisites like engineering physics and chemistry. So once if you know the basics of all these things, then it is very easy for us to know the what is the chemical bonding, chemical structures, the composition of different materials. All this can be comes under the chemistry. Next, the properties, the physical mechanical properties can be identified with the help of the engineering physics. So these are the some prerequisites which is given to you. So please go through those to read this material engineering. So this is about the overview of the course, that is the material science engineering. And coming to the marks distribution, so here we have SEE, that is for 70 marks, that is the semester end examination. So at the end of your curriculum completion, we have a semester end examination which is going to conduct for 70 marks, and we have another CAE examination. So CAE is continuous internal examinations. So that means in between of 2.5 and 2.5 syllabus. So total we have 5 modules. So first 2.5 syllabus will give an internal examination, and other 2.5 will give another internal examination. So like that we will divide two internals for 30 marks. Okay, we'll take the average from these two, and totally if you see these 70 and 30, it is for 100 marks. So this is how the evaluation process, the marks distribution will be done. And how the lectures are delivered in this are through the help of PPT, chalk and talk we have, assignments we'll give in between the lectures, and MOOC videos we won't show, and no open-end experiments because it is only theoretical. Seminars will be conducted from the higher semesters, since it is a just entry to the core subjects. Since it is in third semester, we have done seminars, and mini projects will also be not conducted in this. Videos and others cannot be shown in this. So this is how we have the delivery of the program. Next, coming to the evaluation methodology, how this subject is being evaluated. So the course will be evaluated for the total 100 marks. I have shown the marks distribution. We have SE for 70 and 30 for internal examination. So 100 marks total is being evaluated with 30 marks as continuous internal assessment, CIA. Continuous internal assessment is for 30 marks, and 70 marks is for the end semester examination. So this CIA is conducted for a total 30 marks. Okay, the whatever the 30 marks we are distributing, that is the continuous internal assessment for 30. So in this 20 we are giving for the internal examination, and 10 marks is for alternative assessment tool. So CIE, the continuous internal assessment, is for 20 marks, and other 10 marks is being given for the alternative assessment tool. So this AAT can be used like giving the technical seminars, video lectures for just 5 to 10 minutes. Okay, new topic, if any topic is given to you based upon this material science, okay, this can be given to for 5 to 10 minutes, like a seminar or a video lecture you can post. Okay, so this is called as a AAT, alternative assessment tool. So this helps us, any student, to bring his ideas to present, how to present. Okay, all this can be done with the help of this AAT tool. So this is how the internal 30 marks is being distributed. The 30 is again distributed to 20 plus 10. 20 is for internal assessment, whatever the syllabus is there. So within the syllabus only the exam is conducted. And the 10 marks is for the alternative assessment tool. Whatever the seminars you can give, technical talks you can do, or any assignments we can give. So like that, the 10 marks are being distributed. Coming to the SEE, so in the SEE semester end examination, we have totally for 70 marks, and the duration of this will be 3 hours. And the syllabus for the theory course is divided into 5 units. So 5 modules. 5 modules are nothing but the 5 units. So here units are being called as the modules. So each module will have its own syllabus. So total 5 modules the course is being divided, and here each module carries the weightage. Okay, so the question paper, how the pattern of the question paper will be here, 2 full questions with either or choice will be drawn from each module. So from each module you'll get 2. That means, so 5 modules means you'll get 5 into 2, that is 10 questions can be seen in the SEE question paper. So each carries again 14 marks. Clear? So 14 marks means either choice will be given or AB will be given. So out of 10 you need to write 5 questions. So 5 into 14. 70 marks. Okay, so from each module you'll get two questions, A B like that. So 5 into 2, 5 modules into 2 questions, so total 10 questions. In these 10 questions you need to write 5. So in this again 5 you have AB, 7 marks, each question carries 7 marks, so 14 marks here you will get. So 14 into 5, total 70 marks. So this is how your SE paper is being designed. So now evaluation methodology. So the expected percentage of cognitive level. So how the level of question is being understood by the students, how the question is being designed based upon the Bloom's taxonomy. So if you see the percentage of the cognitive level, here 15 percentage of remember is there. So since it is under third semester only, okay, so we have a little bit of remember in the question. So you need to remember some uh, things in the syllabus or the subject. So almost 15% of the things you have to remember and you have to represent in the examination. So coming to the understanding, so try to understand the question. So almost 35% of questions will become under the understand Bloom's taxonomy. So you need to understand, try to understand the question and you have to represent in the examination. Let us 50%. So 50% comes under the apply. So you need to apply. So what? Suppose if any question is given to you in terms of application level, so you need to try to write the question in terms of that application. So like that, analyze, evaluate will not come under your third semester. So these may come for the higher semesters or higher programs like PG, okay, or in the laboratories also you can see the evaluation and analyze. Okay, so since you have only the subject is under third semester, so these three levels, remember, understand and apply, these three Bloom's level can be seen in the SE question paper. Okay, and these analyze and evaluate can be seen in the higher levels of your programs or the in the laboratories you can see. So as we discussed the continuous internal assessment, how the continuous internal assessment marks are distributed. So to get a clear idea, so what we are doing here, as we discussed in the previous slides, CIA is being conducted for total 30 marks. So this 30 again divided into 20 plus 10. So 20 marks for continuous internal examinations and 10 marks is for AAT, alternate assessment 2. So this 20 marks of CIE, so what we are trying to give, so the 20 marks for mid 1 and mid 2. So total 2 mids will you have. Total CIE you have 2, CIE 1 and CIE 2. So CIE 1 is designed for 10 marks and CIE 2 is designed for another 10 marks. So totally 20 marks you have. Now coming to that AAT, that is alternate assessment tool. Again AAT is divided into 2, AAT 1, AAT 2. Again this AAT is divided into 5 and 5. So 10 plus 10, 20, 25, 30. So you get total of 30 marks here. So this CIE what we are trying to do, 20 plus 10. So this 20 again we are splitting into two midterms, mid 1 and mid 2. That's CIE 1 and CIE 2. And the AAT for 10 marks, this AAT again we are splitting into 2, 5 plus 5. So total you are getting 30 marks. And semester end examination is for 70. So total is 100. So this is how we are dividing the marks distribution for the CIE and SE papers. So CIE exams are conducted at the end of 8th week of the semester. So from the starting of the semester after 8 weeks. So after 8 weeks means almost 2.5 units, 2.5 modules of the syllabus will be completed. So for those 2.5 modules, after completion of the 8th week, once midterm, that is the first CIE will be conducted, and another 8 weeks, that is after starting of the semester, that means the 6th semester, 6th week, the other CIE is being conducted, that means CIE 2. So first CIE 1 is conducted at the 8th week of the semester start, and the other semester, another CIE 2 is being conducted after the 6th week, 16th week. And this semester, each semester again, as we have seen this splitting of the marks, 10 and 10. So each mid is being conducted of 10 marks and duration is 2 hours. So this is how the CAE will be conducted for 8th week and 16th week of the semester. And you have again 5 descriptive questions in this, out of which 4 questions have to be answered. You have total 5 questions given to you. So in these 5 questions, you have to attempt 4 questions. Next is the alternative assessment tool. So what are the remaining 10 marks is there out of 30. So that 10 marks is being split into AAT1, AAT2. So what we are giving this AAT1 and AAT2 means, so either we can give concept videos or technical talks or complex problem solving. So these 3 type of things we can give for 10 marks. Either you can give some concept videos. So we'll give some topics. Based upon those topics, you have to uh, bring out some good video. Okay, so those videos we'll see, and based upon your performance, based upon your presentation skill, we'll give the marks. Or technical talk. These technical topics will give. So these technical topics you have to present with the help of PPT. For that you'll get another marks. And the other things, complex problem solving. So these are some of the categories where AAT comes under. So that is how you can see the distribution of the marks in this subject with the help of AAT, CIE as well as SCE. Now coming to the course objectives. So we have seen the complete overview of the course. Now coming to the objectives. So what objectives student will try to learn after reading the complete material science engineering, after knowing the knowledge. So first one is the fundamental knowledge of crystallography and phase diagrams under various chemical compositions of ferrous and non-ferrous materials. So the student will have the fundamental knowledge of the crystallography, how the structure of the material is there, it will be and how the change of phases can be easily identified, and various chemical compositions can be identified for ferrous and non-ferrous materials. So it is very easy to understand. Okay, so these are the objectives we are trying to give, so that the students will try to learn all these things. Once if you come out from the program, the mechanical behavior of materials, phase diagrams, heat treatment, failure of materials, and applications with recent materials. The third one is mathematical modeling of determinant structures to present a wealth of real-world engineering examples, how material science is useful in engineering practices. So all these are the course objectives where the student will try to learn. He will try to learn all these things. Okay, as a teacher, we'll try to teach all these objectives to the students, so that the student will try to learn all these things. So once if the student knows all these things, then he can easily apply the concepts of these material science to the real world applications. Now, based upon the objectives, these outcomes are being defined. So in the earlier slides, we have seen about the outcome based education. So we are setting some goals, some outcomes. So based upon these outcomes, whether the student is achieving or not, the performance of a student can be identified with the help of these goals, that is the course outcomes. So one by one we'll see. So what is the first outcome? So after successful completion of the course, the students should be able to. So after completing the complete course of material science engineering, the students should be able to learn all these outcomes. Okay, so what is the first one? Recall the concepts of basic crystallography and imperfections of various crystals for improving the performance of materials. Okay, so recall. So recall comes under remember. Okay, this is the level, Bloom's level. So what he's trying to do, he's trying to remember all the basic concepts of crystallographic and imperfections of various crystals for improving the performance of the material. So this is the first course outcome from the material science engineering. Next is the identify the atomic packing factor of unit cell of various crystal structures to study the properties of metal. So identify, this is the Bloom's level, and what is the thing you are trying to hear? Atomic packing factor of unit cell. We are trying to identify the atomic packing factor from unit cell of various crystal structures. So after doing this, what is the outcome of that? What is the outcome? If you know the atomic packing factor, what can you find? You can study the properties of material. So this is how the outcomes are designed. We are trying to identify. After identifying, we are trying to find out the atomic packing factor. So what is the use of doing that atomic packing factor is to study the properties of materials. So this is how you're trying to design the outcome so that the student can easily achieve these outcomes after completion of the course. So this comes under apply level. The third one is choose the percentage of chemical compositions of various materials. So what is the use of this? If you choose the composition of materials, so what happens? To determine the proportions and identify of the major oxides of the material. So once you know the percentage or composition of the material, then it's very easy to determine the proportions and identify the major oxides in the material. So like this, you try to apply these things to different products when you know all the chemical compositions as well as the properties of the material. The next one is, the fourth one, explain the concept of phase diagrams and the basic terminologies associated with metallurgy. So if you explain the concepts of the phase diagrams and basic terminologies associated with them, so what we'll do, we can use to construct and identify the phase diagrams and reactions. If you know the concept of the drawing of the phase diagrams, then it is very easy for us to construct and identify the different types of phases and different types of reactions at that compositions. So this comes under again to understand concept. Next one is the experiment with the structures of the materials at different levels of crystalline metals. So if you experiment with different structures of materials at different levels, so what happens? What happens is, for calculating atomic packing factor and coordination number. So all these are interrelated to your syllabus, so that the students will be able to learn all these things when you come out of the course. Next one, explain the features and classifications of new class materials for better performance and low cost and less dependence on important strategic and critical material. So you need to explain, after knowing all these things, you need to explain different types of materials, classifications of materials. Once you know the classification of material, it is very easy to select the exact material to the corresponding product. So this is how you will do all these outcomes. So these are some set of goals for the students, and based upon these set of goals, the performance of the student can be analyzed. And you have total 12 program outcomes. Okay, so since it is a mechanical engineering department, we have total 12. In this, 6 are technical and the other 6 are non-technical program outcomes. First one is the engineering knowledge. So you have to apply the knowledge of engineering like mathematics, science, engineering fundamentals and engineering specialization to solve the complex engineering problems. So in order to solve the complex engineering problems, you need to apply the engineering knowledge. So this is the first program outcome. And the second is problem analysis. You need to identify, formulate, review research literature and analyze complex engineering problems. So based upon the program outcome, you have to try to design what are the complexities there in the given problem. Third one is design development solutions. So you need to design solutions for complex engineering problems in the design systems, component or process they meet the specific needs with appropriate considerations for public health and safety. So all this also you need to consider. So not only designing or developing the solutions for the complex problems, but you need to consider the public health and safety also. That is very, very important, and environmental considerations. Fourth one is conduct investigations of complex problems. Again, you need to do based upon the research-based knowledge and research methods, including design of experiments, interpretation of data, synthesis, everything comes under the investigation. And modern tools you have to use. You have to use the different modern tools to teach them. And the engineering and society apply reasoning informed by the knowledge to assess societal health, safety, and cultural issues and the consequently responsibility. So all these things you need to consider when you go with this outcome. And the first six are about the technical thing, and coming to the other six, that is the 7, 8, 9, 10, 11, and 12 comes under the non-technical, environment and sustainability. So everything, so based upon the environmental activities we have to consider. Ethics, you need to follow the ethics, professional ethics, responsibilities for doing any engineering practice. Individual and teamwork. So teamwork is very, very important. So functional effective, you want to get the effectiveness of the work. Okay, teamwork is very, very important. Communication. So communication of affecting on complex engineering problems. So one cannot be do all the six. Okay, you have to have a good communication. Project management and finance. Demonstration, knowledge, understanding of the engineering and management principles, and apply these to one own risk. So okay, all these are the project management and finance. And lifelong learning. So the last program outcomes is the lifelong learning. So recognize the need for having the preparation and ability to engage in independent lifelong learning in the broad context of technical change. So based upon the technological change, one needs to have a lifelong learning. You have to build up the lifelong learning based upon the change in the technology. So these are some of the uh, program outcomes. And coming to the how we are getting the strength of these outcomes. So based upon the outcomes, okay, these POs are having strength. So three means high, two means medium, and one is low. So in this, since we are applying the engineering knowledge, it is having a high strength. So how we are getting these three, one and one, we'll see in the later slides. So this is how we'll design we assess the program outcomes. And PSO, program specific outcomes. So in this you have three program specific outcome, but for the materials engineering, the PSO is mapped. PSO 1 is mapped. Okay, so that is the focus on ideation and research towards digital manufacturing in product development using additive manufacturing, CNC simulation, and high speed machining. So if you learn that material science, then it's very easy for us to apply in developing the product and selection of material. And based upon the POs and CO mapping, we're getting the strength. Okay, what are the CO? That is the course outcome is there. If it is being mapped to the program outcome, then you can map here. So like that, every CO will not be mapped to the PO. So you have to check clearly whether this mapping based upon this number of key competencies here. Okay, so here you can see here the CO PO mapping. The first CO, whatever the CO we have, total 6 COs we have. So this CO is mapping to PO1 and PO2. And the number of key competencies, here you have 1 and 2. So that's why you are writing 2. So these key competencies you are getting from the PSOs. So like that, for every CO, you have to check which PO is mapping, and you have to give the number of key competencies. So based upon the key competencies only, so like that, for every CO PO, you have to check the mapping and you have to write the number of key competencies based upon the POs. So like this you have to write. For the first CO, the PO is having 2, PO2 is having 2, like that. Since we are having only one PSO, PSO2, PSO3 is not mapping for this subject. Only PSO is mapping. That's why this PSO, again, it is mapping to CO4, which is having 2 number of key competencies. So like this, you have to map your PO and PSOs. And based upon those mapping, you are getting this percentage of key competencies which are mapping for CO with PSO and PSOs. Now, the strength, how we are getting that strength means, so based upon the values here. So if you see here, 0, when it is ranging with 0 to 5% is no correlation. You get a strength of 2 when it is in between 40 to 60, that is moderate. And 1 to 5, again less than 40%, you will get low. 60, more than 60 percentage, you will get 3. So since in the previous slide almost you are getting 60, 60, okay, so here 100 you will get 3, strength of 3, 3, 3. So since here you have very less values, you are getting only 1, 1, 1, 1 strength. So based upon these ranges, you have to identify which zone it is being formed. So totally 3 plus 3, 6, 6 by 2, 3. 1, 2, you add, totally you'll get 6, again 6 by 6, 1. Here 1 by 1, 1. 3 by 3, 1. So here you're getting the total average articulation matrix with the help of PO and PSO mapping. So assessment methodology is how we are getting this by doing the indirect and direct assessment. So what is the direct assessment? So direct assessment to the students can be given by the CA exams, SE exams, seminars we can give, and 5 minutes videos, open assignments we can give. So all these are the direct assessment methodologies. What is the indirect means? Based upon the feedback and end semester feedback. So these are the assessment tools. Based upon the assessment, the student performance can be identified. So we have direct and indirect assessments. And coming to the syllabus, totally we have 5 modules. First module is structure of crystal solids. So in this have the basics of all the atomic structures, bonding in solids, coordination number, atomic packing factor. So all this can be identified. The line defects, point defects, everything can be identified in the module 2, module 1. Coming to the module 2, you have the phase diagrams. So how the material can be changed from one phase to other phase, how to draw the phase diagrams with the help of different compositions. All these things can be studied with the help of this module 2, that is the phase diagrams. Coming to the 3, 4 and 5, you have engineering materials 1, engineering materials 2 and 3, engineering materials 4. So different types of engineering materials based upon your applications, based upon the new research, what are the different materials are coming for different applications can be studied in these materials, engineering materials 1, 2, 3 and 4. That is the module 2, 3, 4 and 5. So you have metals, non-metals and the ceramics. So like this, the modules have been classified. Metals will study, non-metals and the ceramics. So all these are the different types of materials you will study in the module 3, 4 and 5. So once if you come out from the program or from this course, so the students are able to learn all the course outcomes what we have designed. So based upon those course outcomes, the performance of the students can be identified. And these are some of the textbooks given to you to refer, okay, to study the material science engineering. Sydney Havner, Introduction to Physical Metallurgy, and Donald Thompson, Essential of Material Science Engineering. So as we discussed, you have some prerequisites to study the material science engineering physics and engineering chemistry. Like that, you have the physical metallurgy. So all these things you can refer, you can get the clear idea about what is happening inside the material science engineering, what are the different types of properties you have, what are the physical, chemical properties you have. So all these things you can study, and also you have some reference books, Metallurgy and Material Science Engineering by Kodigiri and William Castler, Material Science Engineering. So these are some of the references books. And of course, the course plan is also being designed based upon the curriculum as well as the assessment examinations. So first we will discuss about the OBE, what is OBE, everything in the first class. Then next, the coming to the modules. Slowly, every module is being presented in the classroom with the mapping and from which reference you are taking. Everything is being have a good plan of course, so that it is very easy to understand for the students. So for every topic is being correlated to your CVOs. So like this, you have unit, cell, space, lattice, like that for every unit. Each topic is being mapped to your CO, and from which textbook you are taking and from which reference you are taking, everything is being shown here. So next is problem solving, case studies. Okay, so different types of, we'll give the course plan before. So based upon this course plan only, the course content will be delivered in the classrooms. So after that, discussions of definition and terminology, discussion on question bank. So for each module you have the definition and terminology as well as the question bank. So this is how the course plan is being conducted in the classrooms. So this is all about the OBE as well as how the course plan is being conducted for the material science engineering, how the course overview, course outcomes are designed for the students, as well as the marks distribution for CAE, SE, and how the pattern of the questions will be there. What are the cognitive levels, different cognitive levels based upon the Bloom's taxonomy, and based upon the course outcomes. Okay, so how the students' performance can be identified, all these are explained in our OBE session. Thank you for having good time. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.